Hey Marcus, let's check this one out, buddy. A lot of these are probably like throwing your mind for a loop because the answer key is rationalized, right? We always have to rationalize our denominator. So let's kind of work through this. Remember, I can use the quotient rule here, which basically means I can just express this as the root of this as a whole fraction, right? Kind of a small thing, but instead of taking the root of the numerator divided by the root of the denominator, I can just take the root of the whole thing and express it as a quotient. 2/3 doesn't really help me. It's not going to divide into anything. It's still a fraction, so that kind of sucks. But we can do the exponent rule here, and I can get this down to the root of 2x squared over 3. Okay, because that x is going to go away, and that reduces that just with the exponent rule. Still doesn't really help me though, so I'm going to split her back up now. The real only thing I wanted to do with that is just get rid of that. Just reduce that exponent a little bit. Now we have to rationalize this because recall that we don't want zeros and we don't want irrational numbers as our denominator. How do you make this is a whole thing? How do you have a whole thing that doesn't really end and goes on forever? Doesn't make sense. So now we have to rationalize the denominator. I'm going to multiply both sides by root 3. Whatever's in the denominator, just make it a fraction by itself. That's how you do these. Now up top, because I have two numbers underneath square root signs, I can use the product rule. So I can multiply them without taking the square root yet. So that's going to give me 6x squared. And down here, that's going to give me root 9. Now we can go a little bit further. This x squared is a perfect square, and this 9 is a perfect square. So we'll evaluate those. The square root of x squared is x times root 6. I can't do anything with 6. I can't factor out a perfect square. And the square root of 9 is 3. So that's where that answer comes from, because they use the quotient rule. Where am I at? Up here. They used the quotient rule, but then they had to rationalize the denominator. All right, so I hope that helped. Check your other ones because they're probably similar like that. And again, whenever you have a root in the denominator, that's generally bad news. So you have to do whatever you have to do, reduce it as much as you can, but then before you punch in your final answer, make sure to rationalize that. Let me know.